So now we're on the top of page 3, and we've covered moving a graph up and down, or left and right, or reflecting the graph, and now we're stretching or shrinking it. So let's compare the vertical stretching or shrinking and the horizontal stretching or shrinking. So let's see visually what the difference is. So it looks like here we have y equals a times f of x. So we have this number a out in front, some number a, times the entire function. Whereas down here we have this number c, but it's not being multiplied times the whole function out in front like that. It's being multiplied to only the x. So down here it's c times only the x. So if you have a number and it's being multiplied to the entire function, that's when you have a vertical stretch or shrink. And if you have a number times just the x, then that's going to be a horizontal stretch or shrink. And a and c can be any real number, basically. If you take the absolute value of a, and that turns out to be greater than 1, then that's called a vertical stretch. But if the absolute value of a is between 0 and 1, then that's called a vertical shrink. And then if the absolute value of c is greater than 1, then that's called a horizontal shrink. And if the absolute value of c is between 0 and 1, then that's called a horizontal stretch. And then the last thing to note is if that number's negative, so if a is less than 0, then you're also going to have a reflection across the x-axis, and that's due to what we talked about on the bottom of page 2. And then similarly, if this number c is less than 0, so if it's negative, you'll also have the graph being reflected across the y-axis. And in general, how I apply these facts is if we have this top situation, if we have a number times the entire function, then multiply all the original y values by the absolute value of a. And then down here, if you have a number times just the x, then divide all the x values by the absolute value of c. I guess I should say divide all the original x values by the absolute value of c. So these two notes over here are what I'm actually going to use. So definitely make sure to write this down, because this is what's going to help you achieve these vertical or horizontal stretches or shrinks. So let's see how to apply these in the next example. So for this example, a graph f of x is shown at the right, and graph the following. And then we have parts A here, and then B, C, D, and E. So all these parts are going to be based off of this one graph here. And so what I'm going to do before we even get to part A is I'm going to look at this graph. This is f of x, and I'm going to write down the points in a t-chart. So we have our x values and we have our f of x values. So these are all being written in this t-chart, the points that we see here. So the main points that are explicitly written on this graph is this one, -5, 0. Then we have -2, 2. We have 0, 0. We have 2, -4. And 4, 0. And I'm going to, on all the parts A through E, I'm going to actually write this. I'm going to write these values down in all these t-charts that are already in here. So x and f of x, and then I'm just going to rewrite these because these are going to be our starting points, and then we're going to use these to help guide us in our transformations. So we have negative 5, 0, negative 2, 2, 0, 0, 2, negative 4, and 4, 0. I'm just copying these ones. So these points come from this original graph. And just to save time, I'm going to do it for all these as well. So for part B, x, f of x, the points were negative 5, 0, negative 2, 2, 0, 0, 2, negative 4, and 4, 0. I'm going to do the same thing here. D, x, and f of x, negative 5, 0. And I am not going to do it for part E, and once we get to that part, you'll see why. So now that was just prep work. Now let's do the actual work. So part A, we have a new graph, g of x, and it needs to be 2 times f of x. So this is our a value. A equals 2. So this is a number times the entire function. Also, if we take the absolute value of a, this is then the absolute value of 2, which is 2. So if we have a number times the entire function, that means it's a vertical stretch or shrink. And then we found the absolute value of a turned out to be bigger than 1. So it's a vertical stretch. I'm going to write that down here. So we have a vertical stretch because the absolute value of a turned out to be bigger than 1. And then let's see what we said up here. It said if we have a vertical stretch, meaning if we have a number times the whole function like we do, then we need to multiply all the original y values by the absolute value of a. Well, we just found that the absolute value of a is 2, so what we need to do is multiply all the original y values by the absolute value of 2, which is 2. So what I'm going to do is add on a new column. Here are our original y values from this graph here. Here's our x values, and here's our y values. So this column is the original y values, but we want to find out what y values are there for g of x, because this is the graph we're trying to graph now. So I'm going to kind of extend it. So now we want the new y values. We're going to take each of these original y values and multiply them by 2 to get the new y values. So 0 times 2 is 2. 2 times 2 is 4. 0 times 2 is 0. Negative 4 times 2 is negative 8. And 0 times 2 is 0. Now what this is doing is we have our x values, and these are our new y values. So we would plot these points. We have negative 5, 2, negative 2, 4, 0, 0, 2, negative 8, and 4, 0. These would be the points on our new vertically stretched graph. And just to save time, I've already included the graphs for you. You would graph it yourself, but I'm just going to show you that we do have these points on this graph. And I'm sorry, I do see a mistake I already made. I don't know why I want to do this. Of course, if we're multiplying by 2, 0 times 2 is not 2. I should have put a 0 here. Sorry about that. Just like I did with this one. So, our values in this column, make sure that you fix that mistake that I made. We should have 0, 4, 0, -8, and 0. Now, we'll see we have the points -5, 0. That's right here. -5, 0. And then -2, 4 is this point here. 0, 0 is this point here. 2, -8 is right here. And then 4, 0 is right here. So what this is saying is you can write down the original points in the original graph in a T-chart. And then using the information that we know, we found out that it had to be a vertical stretch, so we had to multiply all the original y values by 2. So we add kind of a new column on, multiplied all these original y values by 2 to get these y values, and then we use the original x and the new y, plot these, and that gives us our new vertically stretched graph. And you can see that it does look like a stretched version of this graph. Everything's just kind of vertically pulled up and down. And so if you didn't have this graphed for you, you would come up with these points and you would plot each of these 5 points, and then you would use the original graph as a guide. So you see, oh, I need a straight line between these two, I need a straight line between these two, but then it kind of goes down and curves. So that's what you would follow down here. You would say, okay, once you have these points plotted, you would know to draw in a straight line between these two, a straight line between these two, and then the rest from here, curve it down and come back up. So let's do another one on the top of page 4. Well, this one is similar to the one we just did, part A, because it's still a number multiplied to the function out in front. Here the number was 2, but this time the number is a half. So here, this is a number times the entire function. And then if we take the absolute value of that number, we get a half. And then a half is between 0 and 1. So if we look back at the chart, that would be called a vertical shrink because the absolute value of that number was between 0 and 1. So we have what's called a vertical shrink. And since it's vertical, we are still going to multiply all the original y values by that half value. So we're going to multiply all the original y values by the absolute value of a half, which is a half. So I'm going to add a column. This is going to be our new h of x, right? The name of this graph is h of x, so I'm writing h of x there. And I'm going to take these numbers here, these are the original y values, and this time we're multiplying each of them by a half. So 0 times a half is 0, 2 times a half is 1, 0 times a half is 0, -4 times a half is -2, and 0 times a half is 0. And we are going to plot these x values corresponding with these new y values. So here are new y values. So let's look at the graph. Again, I already have it there for you, but we have the points -5, 0, that's here, -2, 1, that's here, 0, 0, that's here, 2, -2, down here, and 4, 0, which is there. And it's still based off of that original f of x graph, so we would know after we plot these points, we have a straight line, then a straight line, then curved all the way around. All right, and now let's look at C and D. Well, even E. This time, the number is not out in front. It's not the number times the whole function. This time, see this 2? It's multiplied just to the x. Or this half is multiplied just to the x. Or this -1/2 is multiplied just to the x. So in that case, now we're looking at horizontal stretches or shrinks. That's when you have the number times only the x. So this time, instead of multiplying all the original y values by the absolute value of a, we're going to be dividing all the original x values by the absolute value of c. So let's see how that goes. So this time we see it's a number times the x only, and the number is 2. If we take the absolute value of 2, we get 2, and that's bigger than 1. So let's see what that chart tells us. So we know it's this case down here, and we just saw that the absolute value turned out to be bigger than 1, so we call that a horizontal shrink. So we have a horizontal shrink, and that's telling us then to divide all the original x values by the absolute value of 2, which is 2. So it's a little bit different than parts A and B because we are not changing the y values. This time we're changing the x values. So instead of adding a column to the right, I'm going to add a column to the left next to the x values. So these are our original x's, and then this is going to be our new x's. So these are the original x's, and these ones are new. So we need to take each of these x values and divide them by 2. So we had -5. If we cut -5 in half, we get -2.5. If we divide -2 by 2, we get -1. If we divide 0 by 2, we get 0. If we divide 2 by 2, we get 1. And if we divide 4 by 2, we get 2. So this time, we're starting with this x value and dividing it by 2 to get our new one. So we're going this way. And so this is our column for our x's, and we're keeping the original y values this time. So these are our x's and their corresponding y values. So -2.5 comma 0, that's right there. -1 comma 2 is right there. 0 comma 0 is right here. 1, -4 is down here. And then 2, 0 is here. And then we fill in the similar shape of the graph. And then part D, similar to C, because once again, we have a number times the x only, and then we want to look at the absolute value of that number. The absolute value is 1/2, and 1/2 is between 0 and 1. So if you look back at the chart, for horizontal stretches or shrinks, if the absolute value of the number that's being multiplied is between 0 and 1, then we call that a horizontal stretch. So this time we have a horizontal stretch, and we are supposed to again divide all the original x values by the absolute value of a half, which in this case is a half. But think about what this is saying in terms of fractions. Well, we know how to divide fractions. If you divide a number by a half, that's the same as multiplying by the reciprocal of 1/2. So this is the same as multiplying by 2, because the reciprocal of 1/2 is 2. And since we're changing the x values, I'm going to write my new column to the left of the x values. And these are going to be our new x values. And these are our original x values. And we just found out that if we want to divide these numbers by a half, that's the same thing as multiplying by 2. So just to make it easier on ourselves. So -5 times 2 is -10. -2 times 2 is -4. 0 times 2 is 0. 2 times 2 is 4. 4 times 2 is 8. So these are the x values that we want to use, and we're going to use the original y values. And if we plotted these, we have -10, 0, that's here. -4, 2 is right here. 0, 0 is here. 4, -4 is down here. And 8, 0 is here. And you can kind of see this, the graph really did get horizontally stretched out a lot. So that's that one. And then part E, the only difference between part E and part D is that there's a minus in front of the 1/2. So for this one, note the minus. What we're going to do is we're going to start with f of 1/2 x. We would ignore the minus, and then whenever you have a minus inside attached to the x, there was a note about that. We are in this case, and it says if c is less than 0, which it is, since we have that negative out in front, the graph is also reflected across the y-axis. So then we need to reflect across the y-axis. And that's the same rule as when we were talking about reflections earlier. If you have a minus attached to the x, then that's always a reflection across the y-axis. But if it had been a minus out in front, then we would reflect across the x-axis. So we are actually starting with this graph, because this is 1/2 x, and then we're reflecting it across the y-axis. So the y-axis is acting like a mirror, and you see this part got reflected across this way, and then this curved part got reflected across this way. And so you just have to kind of make sure that your points are really mirrored perfectly. So for example, -4, 2 now becomes +4, 2. Or -10, 0 now becomes 10, 0. 0, 0 stays the same because it's on the line of reflection. It's on the y-axis. This one down here, 4, -4, reflects over here to -4, -4. And then lastly, 8, 0 reflects over here to -8, 0. And then we would get this graph. So when there's that minus out in front, You start with the one without the minus, graph that, and then reflect appropriately, either across the y-axis or the x-axis, depending on where the minus sign is. And then let's go on to the top of page 5. And now we're going to talk about multiple transformations at the same time.